And today we'll talk about monitoring your containers. Using the Elasticsearch, since I work for Elastic, I'm actually part of our infrastructure team. So we do everything around automation, AWS and stuff like that, Docker containers, testing, and that then is, I always call it a Unix pipe. I kind of pipe the infrastructure work into developer advocacy, so I'm out at lots of conferences doing talks, meetups, sometimes visiting clients. So we want kind of to monitor all the things, both in general, but for this talk in particular about containers. So just to get an idea, who is running more than 10 servers or containers already? Okay, that's few. Very careful, okay. And the next question is then, how do you log? If your answer is kind of, well, we SSH into the boxes and then tail F everything, and you have more than 10 boxes, that is probably not the right answer. So just to get the idea, who is already using something centralized for logging? Okay, what are you using? Elastic, Elk Stack? Anybody? Splunk? That's very nice. Here are the rich people. You're always welcome at Elastic, you know. I don't know Splunk that well. I know it has its advantages, disadvantages, and its price tag. But we can discuss that afterwards. But let's not go into that discussion right now. So what are logs in general? For us, logs are always like you have a timestamp. You might have optionally some meta information, and you have some message. And that message might contain more structured or unstructured data. So you can just throw it somewhere and store it and then do a full text search on that. Or you might want to extract more meaningful information from it. For example, if you have a web server log, like Apache or Nginx or something, you might have something like a return code, how long the request took, what the user was requesting it, all of that stuff. You might want to extract that, and often you have just messages where you want to keep the original message. So now that we want to store that centrally, what are kind of our options? And like the 2-minute intro to that is, well, Elastic, the company, which started off as Elasticsearch, has Elasticsearch. Originally for full text search, that was kind of the history. Started in 2010, that was the original logo. Our Photoshop skills were not that great back then. And the tagline was, you know, for search. And that's still working great. If you're searching on any of these 3 sites, which I probably don't need to explain, behind the search box, there's always Elasticsearch doing the actual searching for you. And then people wanted to do more, and those started off as community projects. Their authors probably don't want to hear it that they were bought in, so we always say they joined the family. But we have these 2 other products which then joined the family. So Kibana is the visualization. You have lots of data and want to visualize it somehow and see what is going on. And Logstash, as the name already implies, you can get logs, but it's absolutely not limited to logs. We have more than 200 connectors, I think. So you can read data from lots of sources, parse it, and enrich it. Enrichment would be something like you have an IP address and you want to get the geolocation for that. And then store it somewhere else. That somewhere else is often Elasticsearch, but it doesn't have to be. So you could throw your stuff on Amazon S3 if you generate flat files. So there's kind of the glue keeping your stuff together and getting data from A to B. And that worked very well. People called it the Elk Stack, Elasticsearch, Logstash, Kibana. Most people are still referring to it as the Elk Stack because, yeah, you have the animal, and it's very easy to remember. Everybody calls it the Elk Stack. No, we don't. It's actually very fitting. But no, not right now. That's a first. And take the focus back. And the Elasticsearch is widely used. For example, CERN, with their thousands of computers, they have centralized logging. Salesforce, I think for their cloud offering, they log everything into Elk. Goldman Sachs is a different story. I think they mainly do auditing and compliance, because every now and then somebody does something bad, and then they have to pay a big fine. And at some point, they figured out it's probably cheaper to do proper auditing than paying the 100 million fine every few years. We see how it turns out. So that was all nice and worked well. The only complaint was, since Logstash started off as Ruby and is now JRuby, you would always need to install the JVM just for logging. And if you're a Java shop, that is fine. If you're more on the .NET side or any other programming language, just adding the JVM or at least the JRE just for logging is kind of a pain, and people were very reluctant to do that. That's why we added this little fellow. It's called Beats, written in Go, so you get native binaries, so they can collect information and just forward it. They don't do any parsing or enrichment. They're just agents, forwarders, shippers, whatever you want to call them. So they will just gather information and forward it. Problem was, that doesn't work well with the elk, because there is no B in elk. And we didn't really kill it. That is maybe too drastic, but let's just say the elk is retired and living happily ever after. So we tried then with this one. This is the Belk, or the elk B, where you can see we have all the letters in there, but at some point we kind of decided, well, this doesn't really scale, and Elastic is all about scaling, because what if we add another product later on? We need to make up another animal, and we need to replace all the marketing again, and it's kind of very cumbersome, and yeah, it doesn't work that well. So that was only temporary. One of our engineers liked it so much, he created stickers, or had them made, before it was even official. So some people even have that as a sticker, though we never did that officially. And then marketing kind of settled on the boring version, like Elasticsearch to strengthen the brand. And whenever somebody does a meetup or any other public event, and they still call it elk, we internally raised the elk alert, and somebody will reach out to them and say, please don't call it elk anymore, this is the new branding, and yeah, we would like this much better, but it's very hard to kill the elk. Like, you just cannot get rid of it after some point. And this is kind of the stack. So you have the lightweight agents, the beats, forwarding data either directly into Elasticsearch or forwarding it to Logstash, and Logstash does the parsing and enrichment. Elasticsearch, which does the storing then, and you can query your data out, and Kibana for the visualization part. And those four are all open source and free, all Apache 2 licensed, so you can just take them and do whatever you want with them. So that is the open source stack. And we recently, like last fall, I think end of October, we had a major version makeover. Since all the projects joined the family at different points in time, they all had their own version number. And it was not really aligned, and even for us it was kind of complicated to keep track of, well, you have Elasticsearch 2.4, you will need Kibana 4.6, Logstash is 2.4, and I think Beats was 1.3 then. And if you ask, like, what is the right combination for Elasticsearch 2.1, I would have no idea. And for most people it was like that, and when we cannot remember it, our customers cannot either. So we changed the version number, everything is version 5 now. That's why Elasticsearch, for example, jumped from 2 to 5. And obviously that is much better, so this is not just another release, this is just 3 times better now, since we skipped so many versions. No, it's just the new version number, you didn't miss that much, it's just version 5 everything, and we're at 5.1.2 right now, and 5.2 will come out soon. And we're not making as much money as Splunk, but we do have a business model as well. This is kind of the description of how we make money. So those with the dashed line around, those are all open source. You can just use them for free. We provide everything hosted. So if you have a rather small cluster and you're on AWS, we provide that on AWS, which is actually a competing service to what AWS is providing. And we have commercial extensions which go always hand in hand with support. So if you need anything around security, monitoring of your cluster, alerting if some specific rule matches, that would be commercial. But that is only a plugin, so you can just add it or you can remove it at any point. Though what we'll talk about today, that is only the open source stack. So that's just for the general ecosystem, and yes, that is how we make money. And pay my salary, for example, but we'll just focus on the open source stuff today. So let's jump into Beats. Since for the monitoring part, the Beats are the most relevant, you just want to install this lightweight agent and forward information. Let's see how that works, and in particular how that works with Docker then, or containers in general. So the first thing we have is Filebeat. Always think of Filebeat like I always call it tail F. over the network on steroids. So that is kind of the general idea. It's just like you're reading a file, everything new that comes into that file, you just take it and send it over the network. Sounds very simple, and it pretty much is. You then can do the parsing. So if you have, for example, a log file and you have the return code, if you have an HTTP request or response, you have the HTTP code in that message and you want to parse it out, you can either still do that with Logstash, or we have a new node type called ingest node that can parse that as well. But let's leave the parsing aside for today. Nice attributes of the Filebeats are they are at least once. So you have your file, and it will just send it over, and it makes sure it is acknowledged before it's actually assuming, okay, this has been sent. So you will not lose any log messages. It supports back pressure. Back pressure means the receiving system cannot keep up at some point anymore and will tell the sender, whoa, back off a bit, not so fast. I cannot keep up, slow down, and once it can keep up again, it will tell it, and then it can send at full speed again. And it supports graceful downtime, which is pretty simple since you're logging mostly to a file. If you just read contents from a file, you have a pointer to a specific location in the file, and you know everything up until here I have already sent, and everything afterwards I still need to send. So even if the other side is not reachable, you just keep that marker, and you don't need to keep anything in memory or anything. You just have this marker and know this file I have read until this point, and as soon as the other side is available again, I can then send it. So what this will look like, you have receivers. Here we are just sending to Logstash. As you can see, our Photoshop skills have improved slightly. Logos are a bit nicer. And we have on the left-hand side, we have lots of beats. These would be our containers or instances. And they just send their information. And they can send to any of the receiving instances. They will just pick one. If that one is not available, they will go to another one. So this can be set up pretty highly available. And how they make sure that you're not losing messages, you have this connection between beats and Logstash at the bottom, and you send a batch of messages. So we have sent the acknowledged part, and now we have read something, and we're sending that as a batch. And only when that has been acknowledged, we will actually mark it as act and gray in the stream of that one file. And only then will it be assumed to have been sent successfully. And if it is not acknowledged from the other side, we will try to resend it afterwards. And that registry file, that keeps track of until where have I sent something in that file. That's the nice thing about files. Since you don't have anything in memory, you don't need to discard something if your buffers are full. You can just keep that marker and know from where to keep going. Other nice attributes is it supports multi-line messages. Multi-line messages are often a pain because it's hard to parse them. But if you have stack traces or something like that, that's normally multi-line. You can do filtering on the client already. For example, you can define a pattern and say, only what starts with, I don't know, error or warn, I want to send over the network. I want to log more on the instance, but I don't want to store it all in my central instance because it's just too much data, and I don't want to burden my network. So you can just already filter out on the client side. And if you already have JSON, you don't need to do any parsing anymore. You can just send the JSON and insert it into Elasticsearch directly. Since Elasticsearch stores JSON, you're good there. So, what does it mean for Docker or containers? We have 101 options, and we'll go through all of them quickly. So, don't laugh. You'll see. So if you have the logging overview, those are your options, and some of them are applicable with our stack, and some you cannot use. So some providers have their own logging connectors. We don't, but we can hook into other processes. So first one is JSON file, which is also the default. Basically, you're writing out the JSON files, and Filebeat runs and just collects the JSON files. Which is very nice because it's very simple. You're sticking to the default. You still support Docker logs. You keep all the metadata from your Docker containers in that. Major downside is, by default, you can change that. Your JSON file will be unbounded, so it will just keep growing and growing. You will need to configure the right rotation. and it might be slow to log in JSON. It might slow down your containers, depending on if you have that issue or not. The alternative would be you run a syslog server. So you can run a local syslog server and then have Filebeat collect from syslog, which is nice because it's super configurable. But well, you need to run your own syslog server. And yeah, multi-lines, you need to parse them again. So it's not that nice, possibly. It is powerful. You have all the features you want, but it's not that nice to actually run your own syslog server, maybe. Journald, yeah, there's pretty much nowhere around the Journald, or at least in the Linux world. Filebeat can not yet collect it, but hopefully soon. So you will just write it into the Journald process. You don't have a log file anymore. It is nice because it's widely available. You can use Docker logs. It has the right metadata. Major downside is Filebeat does not yet support that. It will be pretty certain that we will add that feature in the future, but we don't have it yet. So if you want to use Journald at the moment, there is a community beat called Journalbeat that can collect the information right from Journald. Nice thing is you don't have to write everything out to a specific file and need to reread it from there again. Then there is Gelf, which is supported by default and works and is pretty fast. Downside to being pretty fast is it's UDP based. So there is nothing like back pressure or acknowledgements. If your messages are lost or your receiving side is overloaded, your messages will just get lost, which might be fine if you just have lots of logs and you're more interested in like, yeah, I get most of the stuff, but if my system is overloaded, I don't care about all the details anyway. It's fine. If you want to have all the logs, it's probably not what you want. And the final option is, in your application, you can just log the specific file or volume you have mounted out, which is simple to install, especially if your app supports rotation. Otherwise, you will need to rotate manually somehow. It is very scalable, but again, metadata might be an issue. So you just mount some folder in and have Filebeat run outside and collect those log files and forward them. So as you've seen, we had 101 options. Luckily, it was only binary. So what we would suggest today is either use JSON, the default, use a syslog server if you want to run your syslog server, or mount the volume. In the future, once we support Journald, that is probably the preferred option. Or you want to run the community beat at the moment. Next up are metrics. Metrics are just whatever metrics on the system or application side you have, like, I don't know, how many requests you have, what your average response time is, all these things. That is what Metricbeat is. So Metricbeat has a system module that can collect lots of system information, like what is the CPU doing, yeah, memory, all these things. And we support some services, like this is the current list. It will, of course, grow over time. So if you have one of the web servers, MongoDB, Postgres, MySQL, Cassandra, Redis, we can just ping these services and extract statistics from that and just see how that application is doing. How does that work with containers? Yes, you can just read the data from cgroup in proc, which is part of the system module, so getting the CPU and memory information from a container that is, or historically that was always reading proc, which has a few very nice attributes. So if you have access to the Docker API, you have access to the Docker API, so you can do whatever you want. And just for logging, you probably do not want to have that. So once you have access to that API, you can just stop your containers or start new containers. And maybe your logging system should not be able to do that. Maybe. Depends on your situation. We are more of the opinion maybe you should not do that. So for security reasons, it's maybe a good idea just to rely on proc and not require actually access to the Docker API to access the logs. With proc, all the different container technologies, not just Docker, are supported. So if you want to use one of the more exotic ones, for whatever reason, you can totally do that with proc. It automatically enriches all processes with the information from the cgroup. The downside is since it's not Docker specific, there are no Docker specific informations like the meta information Docker has. It's just not there in proc. And then what people mostly say, but I only have Docker and I only care about Docker and everybody just wants to use Docker. And somebody in the community then said, well, this is actually something we can build. And they implemented something based on the Docker API and they called it Dockerbeat. And I think it reached version 1.0 and they were nice enough to write a blog post on our blog and released it. And I think 1 or 2 days later, Docker sent us, or their lawyers sent us a very angry letter and said, anything that starts with Docker in the name is trademarked to them. And even though it's just a community project and open source and we're not making any money on it, that is their trademark and we cannot use that. So then we didn't have Dockerbeat anymore. Was a bit of brainstorming, where do we go from here? So then we renamed it, so now it's called Docbeat. At first we even thought about just dropping the E and just calling it Dockerbeat, but now we just went with Docbeat. So Docbeat is now available, we just renamed it and it's, yeah, that's the same thing. Sorry for the confusing name, but trademark disputes. And we have also included that into Metricbeat 5.1, which is current version. That has the Docker module included as well. I can show you a demo with that then later on. So you don't need to use the community module anymore. That is actually contained in the Metricbeat module already. It will, of course, require specific permissions. So to run that, you will need to set some read-only permissions on proc, hostfs, cgroups, fs cgroups, hostfs. So you will need these permissions to run the system module. You can take pictures, but A, it's in the documentation, and B, I'll publish my slides afterwards as well. But feel free to take pictures. For monitoring a service, you will actually need to link the service, so your Docker container that wants to monitor it can access that resource. So for example, for MySQL or Apache or whatever, it will just do a request to the service and then store the response of that. So you will need to link those services to be actually able to access that. And the way you should run that is normally as a sidecar. So you just have your own Metricbeat process, and that runs next to your regular containers, and then that can just collect all the information you want to have. Yeah, you can stuff it into your other containers, but that's probably not the idea of containers. And then one of the questions that often comes up is like, is that even fast? Like Elasticsearch, in the beginning you said this was made for full text search, and now we're storing metrics, and this is kind of a very different problem. And yeah, some of our competitors always want to do benchmarks, but our opinion is pretty much this on benchmarks. Even under similar conditions, the results are probably not that comparable. So for example, here we are benchmarking the house cat and the squid, and in similar conditions, the squid is much more intelligent because the house cat is dead. And that is pretty much what all the benchmarks do anybody publishes. That's why we don't publish any benchmarks. So in the recent version, we have kind of worked a lot to make that scenario more powerful or more performant. So previously we only had floats, for example. Now we support half floats as well, so you only get half the precision, but you only need half the disk space as well. And then we have scaled floats as well. Scaled floats is you just store an integer number, but you know it needs to be divided by, I don't know, 4,000 or 100 to get the actual float value. So you're limited in the precision somewhat, but again, you will need less disk space and it will be more efficient. So that is why, even though it's full text search, we have improved both the columnar reading of values and the storage side, so it can handle metrics quite well as well. And then the next beat is Packetbeat. Packetbeat is like network packets. Who's using Wireshark? Few, okay. Wireshark is really nice as long as you have 1 or 2 servers. But if you have more, it gets quite a pain because then you need to capture on all the different systems your network packets, and then you will need to collect them and probably combine them to actually get an overview of what is going on in your system. The idea of Packetbeat is it's using the same base library, libpcap, so it will capture your network packets and then extract the meaningful header information. Meaningful header information would be, it knows you have an HTTP request and an HTTP response. It knows the whole thing took 100 milliseconds, the response code was a 200, and the URL you actually hit was foobar. That's actually all available in the header, and that's what's mostly will interest you. So you can see, what is my average response time? Is my response time getting worse? Do I suddenly have more 500s or 400s than before? Do I have more requests in general? So this is all the information that Packetbeat will extract for you. We support some protocols, HTTP, other databases, DNS, ICMP. So for them, the wire protocol is actually supported, and it will be able to extract from just the request and the response to MySQL, for example. It will know the response or how long the full thing took on the wire was 15 milliseconds, for example. The query you sent was select star from whatever. So it can extract all of that information without actually needing to store the payload. And that way you don't need to instrument your database anymore. You can just do it all on the wire. And if the support for the protocol is not yet implemented, we have something called flows. So it actually knows that it's just a TCP connection, but it still knows A is communicating with B and how many packets and how much traffic. Or if you have encrypted traffic. Obviously, we cannot break the encryption and look into the encrypted traffic without some more complicated setups. But it will still know who is communicating with who and how much traffic is that. And again, this should be run on the side and not in the main container. So, Docker. What containers do we actually have? So we have some containers. Luckily, we started off naming them the right way. So we always had our product name -docker, so we didn't have to rename afterwards. So we have Elasticsearch, Kibana, and Logstash we have. The beats will come soon. They're not yet available, but kind of to run it as a sidecar, that will be available. No firm date yet, but we're working on that, or we're about to start working on that now. And kind of the minimal example to run Elasticsearch plus Kibana to visualize it would be that. That's the latest version. You just run Kibana and Elasticsearch and link the two together. You mount your volume with the data, and that's all you need to actually run the minimal Elasticsearch Kibana example. One thing we had in the very beginning, but we have removed, is latest. Because this will just cause trouble later on. It is nice for testing and development that you just do latest and get the current version and you don't need to care about anything. But what people will potentially do is they will start some cluster for production with 3 nodes, and after 1 year, they want to add 2 more nodes. And if they have just configured that with latest, they will screw up their cluster entirely. That's just to be safe. That is, we had it for like, I don't know, the first 2 or 3 releases in the 5 branch, but since then, latest has been removed, so you cannot even access that. If you have still cached it, you might get weird results on all the versions. I assume very few people do. But yeah. Oh, and one more thing, which you might have seen or might not have seen. Our containers are not on the Docker Hub. We have our own Docker registry. So if you go to Docker Hub and get Kibana and Elasticsearch, those are Docker Hub official packets. They call it themselves Docker Hub specific. And we often get complaints about those, but those are actually not ours. So our containers are in our own registry. I think our main motivation was to actually have better download statistics and like a better overview of who is using what. So you will get the wrong one if you just do on Docker Hub, get me the latest Elasticsearch version. Yeah, and we can actually see how that is going. So we have, that is Kibana. Is it large enough? No. Is that large enough? Yeah, it's probably better. So let's refresh that. So this is generally Kibana, the version 5. So if you have seen an older version, it was more white, or if you have seen a very old version, it was more black. This is the colorful version. Like this is 5 is more colorful. So the main things you will be interested in, we have Discover. Discover is just what data do I have and what can I do with that. Visualize is then you can click together some visualizations on some data you have. And dashboards, you can put those visualizations together to explore your data. So for example, here I've just ingested quite some log files. And let's see what the type is. So I'm monitoring here Kibana and my one Docker container. So the general setup of this is all a virtual machine that is running. The setup is I have everything running in that virtual machine plus a Redis container. And I'm also monitoring that Redis container. So everything that is Docker here, that will be my Redis container with its information. So I can actually filter that down and say I only want that one. So if I click that plus sign, it will filter down, okay, these were over the last 15 minutes. Can, of course, change the time frame. Over the last 15 minutes, these were all the logs that my Docker container created. So I have 30 events over the last 15 minutes. And if you look at one, you can see, okay, this was my type is Docker. And, okay, that is some Redis log. Parent agreed to stop sending diffs, finalizing AOF. So this is one of the log files we have extracted. Or you could just see there's the raw JSON format. This is what the raw JSON message would look like. So this is, since I'm using, for the logging here, I'm using the default JSON logs. And I've just collected those JSON logs with Filebeat. So how to actually do that? Oops, no, not you. Yes, this is the right one. Just to show you how that is configured, which is pretty easy. It is in etc Filebeat, that is Ubuntu, but it doesn't really matter. So what is configured here is I've just said, okay, I have 3 log files I'm interested in here. So var log syslog for the host system, var log Kibana log for I'm just monitoring the Kibana instance, and then I have one Docker container, actually sudo docker ps. So I have one Redis container. This is this one container that is running, and I'm running that as well. And what I'm doing then is I'm collecting all these log files, and I'm forwarding them to Logstash. And Logstash can do some parsing. In my example, Logstash will only parse syslog into nicer messages. It doesn't need to parse the Docker or the Kibana files, because those are already JSON files. So those are already in a structured format. So we can just keep those originally. Just to give you a quick overview of how Logstash does look then. So for Logstash, which does the parsing, it always consists of 3 parts. First, you have the input, which is kind of where do I get my data from. Then you have a so-called filter, which will parse your data. And then you have an output where you want to forward your information. So the input is very simple. We're just expecting Filebeat. We're just expecting Filebeat to forward something running on a default port, which is 5044. Then for the parsing part, we just say, oops, yeah, we're collecting from Redis as well. That is not what I wanted to show you here. This here, for example, is for syslog. And syslog has a specific format, and you want to parse that syslog message apart. So if the type, what I've received, is syslog, I run grok. Grok is basically a regular expression. And I just have this syslog timestamp. In uppercase letters, this is a predefined pattern. You can define your own patterns or just a regular expression. And that will extract that one field and store it in a message syslog timestamp. And does the same with syslog host, data, and extracts all of those informations. And once it has parsed that, it will actually forward it to Elasticsearch, which is again very easy. Here I've enabled security as well, so username and password, those are the defaults. So it's just storing that information into Elasticsearch. What that would look like, so I can now say, no, I don't want to have this Docker filter anymore, go away. So I have my 114 messages again. In the type, oh, I didn't have any syslog messages in the last 15 minutes. So let's say we want over the last 4 hours. I hope we had some syslog messages over the last 4 hours. Yes, we did. And now I could just say, okay, I'm only interested in syslog, filtering down to that. And if we have done everything correctly, it should extract some meaningful information. So you can see, yes, the syslog, those we have parsed out with our logstash rules. So we know, for example, that was the process ID or the program name and the syslog severity. So these we have extracted from that message. And we could, for example, now also search over all these messages and just see, did I ever reboot my machine? I'm not even sure. Let's see. No, obviously in the last 4 hours, I didn't reboot my machine. But I think I fixed my time. Yes. So yes, I've restarted the NTP daemon, since my virtual machine time always goes out of sync if I put it to sleep. So yes, so you can just do regular full text search over all the data here. And then, since we're lazy, we'll just look at a few predefined dashboards. How can I visualize what is actually going on that machine? So since I only monitor my one local machine, this is just one, but you could of course have more. For example, let's see what does our Docker dashboard give us. So, to little surprise, there is just one Docker container running here, but if you had more, this would show you all the Docker containers you have in your system, and you could actually filter down on just the one or the ones you're interested in. By default, you would get all of them. So one of them is running, 0 are paused, 0 are stopped. You can see, okay, how are the Docker images wrapped, how many containers are running, and you can see CPU usage, memory usage, and what is the network doing. And that is actually extracted from the Docker API now, and just sees what is one or more of your containers doing. You can also see the same on the system level for the entire machine. So this is just one virtual machine I'm monitoring. Yeah, you can see how many processes, 101 processes running in total. Let's switch that back to 15 minutes, since I didn't have it running over the last 4 hours. And here you can see, wild guess, which process is using most CPU and memory. To little surprise, it's Java. Especially for memory, like you can see, there's, wait, I'll resize it again so you can actually see it properly. So yeah, Java is what used most memory, then is Metricbeat, then is Node. Who paid attention? What process is Node? Kibana, yes. Kibana by now is a Node and Angular 1 mainly application. And then the other Beats and Docker are using some memory as well. And we can see Redis server, which is actually inside my container, that is also listed here in the processes needing memory. But it's, yeah, pretty tiny. And depending on what you're interested in, you could just focus on, I don't know, the processes, the network, the CPU load, switch to CPU load, which is, yeah, lots of numbers and sum curves, and you can see, okay, my one instance, what is the CPU usage over time? And you have all the different attributes you can jump into here. And then we're actually monitoring the network as well. So let's go to the dashboard at first. This is showing you all the network requests you have on that machine you're monitoring. We don't have any client locations, since this is running on localhost, and localhost does not translate well to geolocations. So that first one is empty, but you can see here, those are all the web transactions we have. Guesses what is a web transaction on my virtual machine? Exactly, that is what Kibana. So all the clicks I'm doing in Kibana here will actually be reflected in the web requests. So it's very self-driving, that virtual machine. Then we have database transactions. As a database, I have running MongoDB here. Those transactions are it's just a Metricbeat MongoDB module that is pinging the database. Then we have cache transactions, that is Redis. And Redis is pinged as well. And I have set it up that Packetbeat is collecting the network packets, then throws them into Redis as a queue. Logstash collects the data out of the queue and stores it into Elasticsearch. If you have a distributed system and you have lots of components in it and you might have spikes, it is very common to have a queue to actually throw your messages into a queue first and then have it consumed out of the queue. Smaller setups normally use Redis. The big ones often go for Kafka. But to keep it simple, I've just used Redis. So Redis is receiving all the network requests, and that is what we are monitoring here as well. And then you can see response times. Most of my response times were very low, like in the 0 or up to 10 millisecond range. And sometimes you have higher response times. We can also do percentiles, errors. Luckily, there were hardly any errors. And you have latency histograms as well. And then you can actually jump into specific protocols. For example, for web transactions, it can tell you, okay, these were the numbers of requests over time in general. How many did you have? What is the ratio of 400s, 200s, 500, whatever, per URL, and you can see these were my top URLs. For example, /server status, that is the URL that will be pinged by the Nginx module. And this doesn't exist, and this is why we get all these 404 errors. Or, for example, we could see what MongoDB is doing, though I don't have any sensible queries running here. You can see, okay, it's running some queries. The throughput is very consistent since it's just a pinger pinging in, I don't know, every half minute or something like that, pinging the MongoDB with that command. But if you have more interesting queries, they would show up here, and you could actually see which are my queries, what is my throughput, and you have the same for MySQL, Postgres. There's also a Redis visualization that is not linked here. And you can see, okay, we have very consistently 3 client connections. We have one server running version 3.2.6, and it's one standalone server. And the most common request it's getting is the ePOL. So whatever service you have, you can pretty easily keep the overview of what it's doing here. Okay. Any questions so far? Yes?
Those dashboards, are they something you put together? Would they come packaged with stuff?
So the question was, the dashboards, did I put them together or not? No, admittedly, I was lazy. But this is kind of, being lazy is a feature in IT. So these dashboards come actually packaged with the beats. So if you download the beats, it will put them into, so if you install the Debian packages, let me cheat, I don't know by heart, but it's all automated. Yes, so if you install the Debian packages, this is where the dashboards will be put. And you can simply run that, and it will import your dashboards into Kibana, and you can just use them. So I didn't do any customizations on that part here. I just used what we had pre-built. But of course, you can customize these visualizations. So if you're interested in, and you want to build your own, you could, for example, say this one, there is a little pen here, which might be a bit small to see, but you can just click on that pen, and then you will jump to the visualize part. And here you can actually see what did you put together to generate that graphic. And you can see, or probably it's too small and you cannot see, but I took the maximum of this specific field on the y-axis, and then the maximum of the blocked, so it would show both the connected and the blocked. So the white space that is always a blocked because it's 0. So we have both of them, and the x-axis is actually a date histogram. So it's just over whatever time frame I select, it will show that. And you can totally customize that, or you can create your own visualizations like that. So that is how that plays together. Okay. Oh yeah, that is something I'm now throwing into all my presentations. We used, or like a week ago I think, we started to have some issues with Elasticsearch servers which were not that well protected. And yeah, like before, people started encrypting your hard drive and then trying to get some Bitcoin from you. And now first they switched to MongoDB, unprotected MongoDB instances, and now they switched to Elasticsearch. And what they do is they take your data, if they're nice, and just steal it and delete it, and leave you a message like you need to pay up to get your data back. If they're not nice, they will just delete your data, leave the message, and will only tell you after you have paid that they didn't take a backup, or they will just not respond. And I hope it's still working. But I thought it would be fun to actually see one of these instances. So the easiest way to do that is that the website is called jodan.io, which frequently scans the internet, and you can just see what is running where. So if we search for Elasticsearch here, it is just giving you a fair number of hits. So you can see we have, for example, I'll make it a little bigger. Yeah, most of these, so what it does is it scans the internet on mainly the default ports, but also other ports, and it will just collect where specific keywords or ports or something are reported back, and it will just scan the internet. For example, here, it just, all the responses that contain the term Elasticsearch, it put into that list, and you can see more than 1,000 it found in the US, etc. So if it's a 401, the people already kind of did the right thing, so they have a proxy to protect their instances. But for example, yeah, luckily here we have one instance on that IP address that didn't protect themselves, and we can just take a look what, if anything happened to that. So what you want to do is you can just do curl, and we can just, yeah, we can do that. Ooh, sorry, my bad. It's Elasticsearch runs on port 9200. Okay, so this is a fairly old version. 2.4.0 is, I don't know, 2 years old or something. Probably somebody started some test instance and then forgot about it after a time. But that is potentially a good target. So what we can then do is we can say, give me all the indices you have, which is basically the tables in a relational database. So cat indices, and we have something, yeah, that doesn't look good. If you have this please read in your data store, that is not a nice sign. So, oops, that's not what I wanted. So what we can do is we can then say please read, just I want to see what's in there. The query is I want to search for everything, and I want it to be easily readable. Oops. And I somehow mistyped. Oh no, actually, why did you pretty equals true? Ah. It thinks I want to pause it. I need to quote that. Yes, that is nicer to read. And you can see somebody, yeah. By now, in the beginning, I think they asked for 0.1 or 0.2 Bitcoins. They've now increased their prices. Now we're at 0.5. I think a Bitcoin is at something like 700 to 800 pounds today, but it's very volatile, so it will change pretty much every day. So yeah, that is what they're asking for today. I assume it's just a test database and nobody cares for it anyway, so they will not get any money. But I've seen that people traced the specific addresses they found, the Bitcoin addresses, and saw that at least a few dozen people actually paid up to receive their data back. So now that we've seen the bad part, How do you actually avoid getting the bad part? Yeah, we've seen that. We have done that. We even got, by accident, the same IP back. So what you want to do is, or by default, Elasticsearch will only bind to localhost. So you will need to explicitly change that. So somebody has changed that for whatever reason, good or bad. So the first thing you should do is, if it's possible, just bind to the private network address, if you have a private network, or just put it into your virtual network. On Amazon, it would be the VPC, put it into a private subnet, so nobody can ever access it. The second thing is, if it must be reachable from the outside, put at least a firewall in front of it. Though I had people who said, like, oh, they had a public IP and they had a firewall rule to block it, but then they screwed up their firewall rules for a few hours, and within that few hours, somebody already stole their data. So yeah, firewalls can work, but make sure they are actually doing their job, otherwise they're not helping you much. And something, I'm not sure how well that works, just use a random port, not 9200, which is a bit more security by obscurity. I'm not sure how much it will help. It might gain you some time, because the attackers will just go for the default ports first, though it won't be a protection long term. Don't make your data stores accessible by the outside. Then the next thing is, if something needs to access your database, proxy it, since Elasticsearch is just based on HTTP. Proxying it is very easy, like you can use Nginx, and it can do SSL plus HT basic auth, so you can protect your database with that very easily. Or we have something, our commercial extensions, we have the security suite, those are included there as well. Of course, our sales guys will always tell you the X specs are better. They have the main advantage. They're integrated into Elasticsearch. The main problem with the proxies is if you have something that goes around the proxy. So if your proxy is all correctly set up, it doesn't protect you if you have some other way to access Elasticsearch if you don't have the proxy. But otherwise, if your proxy is set up correctly, it will protect you. So, concluding. Do containers solve all our problems, especially for stateful services? And my favorite answer is no. They won't. But yeah. So I always compare then the Elasticsearch to actually monitor that to Lego. So you have all these building blocks. It normally will require some assembly, so you will need to install the services. You will need to configure them. In Logstash, if you need to parse something apart, you will need to provide those parsing rules. There are a lot of public rules out there, but you will need to do parsing yourself. So it's not something, a box you buy and it does everything for you, but it is a building block and you can do pretty much anything you want, both for logs, full text search, business data. We internally use it for pretty much anything. So our newsletters, our builds, everything basically goes into Elasticsearch, and we have dashboards for whatever we want to know internally. Yeah. The dashed line, that is all the open source stuff. We provide hosting as well and the commercial extensions, especially if you're a serious company and need security or stuff like that, or for compliance reasons, that is what you will want. We always call this kind of the story how people evolve in our system. So normally, what people do is they start off with the open source version, and then they introduce it at their company, and since it's free, it's just they start it. And at some point, it becomes more and more important, so they need to continue their journey. So what we then offer is we do trainings for developers and operations. We have support for during development. We have consulting services if you want to go live with something and want to have somebody check up your architecture. And we have production support, of course, as well. And that's pretty much it. I've got loads of stickers over there if you want to have stickers. Other than that, questions? Who's using the Elasticsearch for logging already? Just out of interest. Okay. Good. Not yet everybody, so I still have some work to do, but at least somebody. It's a good start.
I have a question. How much of what you said applies to Windows containers? Does any of it work on Windows?
Sorry, come again?
If you're running a Windows container with something like a server core or nano server as a base, can you do the same kind of thing? Is there a Beats version for that, or is it just Linux containers at the moment?
So you mean to run it inside that, or
Yeah, so getting the same kind of instrumentation off a Windows container as opposed to one running on Linux.
Yes, since it's Go, yes, we have the binaries. Everything that can run Go can run Filebeat or Metricbeat or whatever you want to have. Also Packetbeat. libpcap is supported on Windows as well. So Windows is not an issue. What is an issue is AIX, because they don't have Go support. Probably, I don't know if that applies to anybody. But as soon as you can compile Go, we provide binaries to the most common platforms. So I don't know. From small systems to large systems, everything is supported. But it needs to be able to compile Go. Otherwise, you're stuck. There are some alternative implementations in C to forward logs, for example. That is what you would often use on AIX. But normally it's just, yeah, Go and you're good to go. Any other questions? How did the Solar folks like it? The Splunk folks like it.
Looks a lot like Splunk.
It looks a lot like Splunk?
Yeah, I'm not a fan. It wasn't my decision to buy Splunk.
that is unfortunate. Yeah, I've never used Splunk, I must admit, so I don't have a strong opinion. Yeah. Thank you. You will get your extra stickers afterwards. Yes?
You focused on the logging story, but obviously Elasticsearch is a full-on document database. So are you finding customers use it for what used to be called ELK and use it for logging, or is logging just part of what customers actually use it for? So
I'm always careful with database. We're very careful to say, like, Elasticsearch is not a database. We'd call it data store, whatever your distinction then is. Yes, so the logging use case is not even the majority. I think 30–40% of customers are actually using it for logging. Full-text search is very much evolving and going strong, and we have overtaken Solar in use and downloads and pretty much everything, I think. Even though that is also a very complicated comparison, and we don't like to compare it always apples to oranges. But no, we are not focused on the log use case. So we do full-text search, both historically, but this is fully supported and improving all the time. We are doing logs. We are now doing the metrics. What is coming more and more is like going a bit deeper. We've recently bought, like half a year ago, a machine learning company, which was based in London. So you will have some metrics, and the machine learning will then learn what is normal, and will then alert you if something is not normal. So they have like an upper and lower bound, and will just shout like, hey, you're not within that range where you should be. Because right now you can either have people stare at graphs the entire day to learn stuff, which is very expensive and not the most fun job. And the alternative is you can just set some hard rules, like if you have more than X requests or fewer than something, or if your ratio is different. But that is often not flexible enough. So machine learning is one of the big things that is also coming. Like, we are broadening the scope, but we are not kind of forgetting our history. So full-text search, some people use it as their main data store. If that is a good or a bad idea depends on the use case. We're always saying, be careful. Yeah, but no, we're not forgetting like the history, and logging is not taking over. This was just one example how to monitor your containers, because that is, yeah, one fancy thing many people struggle with. Or containers are great because logging and metrics are getting more important. Like, the more distributed stuff you have, the more important centralized logging and metrics get. So we are, of course, trying to push into that direction as well. Yeah, I think we're pretty much out of time. If you have any questions, find me. I'll be here for the rest of the day. And don't forget to grab your swag. Thanks.